Okay, so today's notes, we're going 226, 19. So, trinomial factoring with a leading coefficient, okay? So what we're going to do is we're going to try and factor with a number in front of x squared. And that's what we have. We've got a 2x squared, I've got a 3x squared, I've got a 2x, and I got a 3x, and on the back, same things, okay? So, what we find is that the multiples of 5, right here on example 1, the multiple of 5s will not make an 11. But this will factor, because the 2 is going to help me out, okay? The multiples of 1, they're not going to make a 4. But the 3 is going to help me get there, okay? Multiples of 3 are not going to make a invisible 1, right? They're not. 3 times 1, that's not going to make a 1. Multiple 16, 2 and 8, 4 and 4, they're not going to make a 22. But with the help of the 3, I'm going to be able to do that, okay? So, how does it work? So, what we have to do is we have to check the middle term, okay? To check the middle term, we're going to do what I like to call it the double smiley, okay? And if I were to take a look at the double smiley, if I had an A plus B and maybe an A minus C, my double smiley is these two terms here. Okay, and I'll multiply them, and I'll see if they add to the middle term, okay? If they don't work, we just erase and try something different, okay? So let's try example 1, okay? So one of the things I know about example 1 for sure, parentheses, the easy part that hopefully everybody can get is the 2x squared. Okay? That should be just 2x and x. Everybody agree with that? So for sure I know at least 2x and x because 2x times x is 2x squared. Now the hard part is the 5. There's two ways to make 5. 5 and 1 and 1 and 5. There are two ways to make a 5. 5 times 1 and 1 times 5, okay? Let me do it wrong first so you can see why it's wrong. And I'm going to purposely do it wrong, and then we're going to erase and change, okay? So I'm going to put a plus 1 here and a, nope, I'm not, that's right. Put a plus 5 here. I'm going to put a plus 5 here and a plus 1, okay? Now, we're going to check our double smiley. So what we're looking for is the 11, okay? I already know the 2x squared is going to work. I already know the 5 is going to work. But what about the 11? So we check it. I do my double smiley. So that's my inside term and my two outside terms. Those two make up the middle term. So let's check it. 5 times x is a 5x. And if 2 times 1 is a 2x. And if I add these two, right? If I add these two, do I make an 11? It doesn't make an 11, does it? So it doesn't work. I mean, if I were to multiply it all out, I would get 11. So then what do? Quit and go home? Take a nap? Sounds good. But nope, we can't do that. We can't quit. So let's try it again. So I do know, and it sounds weird to say this, but 5 is 5 times 1, but it's also 1 times 5, right? So let's try a 1 times a 5. Okay, now check our double smiley, okay? So 1 times x is a 1x. 2 times 5 is a 10x. And if I add them together, I get an 11. This is the correct answer. And if you wanted to go and, just go. This times this, this times this, this times this, this times this, you'll get 2x squared plus 11x plus 5, won't you? Do it this times this, this times this, this times this, this times this. You'll get you 2x squared plus 11x plus 5, right? So, what they are is the same problem. One is in what we call standard form. That's in standard form. Exact same problem, but in factored form. They're both the same problem, but one's in standard form, one's in factored form, okay? Let's check number 2 out, okay? So for sure, absolutely, parentheses, 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 parentheses. Where are you going to start? Start with the easy part. Where are you going to start?
With the 3x and x.
Yeah. Everybody agree with Cameron? Now this one's not too hard because what are the multiples of 1? 1 and 1, right? So it's 1 and 1, or it's Watch this, or it's 101, right? We can't go wrong on this. We cannot.
-1 -1.
Okay, good. Derek's ahead of me. I like that. 101. Okay, now Derek said -1, -1. Derek, why do they both have to be negative?
Because it's a -4.
-1 times -1 is a +1, and he will, by the double smiley. You see the double smiley? We're going to get a -1x and a -3x, which together add up to the -4x, okay? Okay? And if you want to multiply it all out to check it, 3x squared minus 1x minus 3x plus 1, it works, okay? Again, this is the factored form of this trinomial. Okay? Okay, number 2, or number 3. Okay, where do you want to start? Okay, parentheses, right? Let's do the easy stuff, okay? Hayden, what's the easy stuff? Let's do the easy part. What do you think?
The easy part, let me look. Okay, so if you have 1, it would just be 1 and 3 something, right?
You're doing the hard stuff. That's good. Let's do the easy first. Let's go 2x and x, right?
Yeah.
Now we're ready to do the hard stuff. See, you were jumping to the hard stuff already because you knew the easy stuff, right? So, 3 is 1 and 3 or 3 and 1. 3 is 1 and 3 or 3 and 1. 3 is 1 times 3 or 3 times 1. What do you think? What do you want to do?
1 times 3.
Okay, Cameron says 1 and 3. Okay, is he right?
Yeah.
Let's check our double smiley. I got a 1x and I got a 6x. Is that going to make a 1? So, we doggone it, we got to erase and do it again. So instead of 1 and 3, what should I put? Let's try 3 and 1. Okay, erase, erase. I need a better eraser, don't I? Okay, now check our double smiley, right? I get a 3x and I get a 2x. Will that make a -1? Maybe. Max? It will if you put a negative here and a positive here. We'd get a -3x and a +2, and that would make a -1x. Is this kind of hard? No, good. Okay. Okay, number 4 is a little bit harder. All right, let's do the easy part. What's the easy part? Okay. Easy part, all right? What do you think? Okay. How about a 3x and x? You guys okay with that? 3x and x? That's the easy stuff, right? Everybody agree with that one? 16. Okay, you ready? 4 times 4. 2 times 8, or 8 times 2. I'll say it again. 4 times 4, 2 times 8, or 8 times 2. And there's also 16 and 1 is 16. Now, what do you want to try? 8 and 2? Okay, let's try 8 and 2. You want 8 here, 2 here, or the other way around? You've been doing your homework. Nice. Totally right. How'd you get that so quick? Just go ahead and say, because I'm smart, Mr. Davies. Yeah, exactly. Now, why is she right? Let's check it out. 2 times x is
2.
3 times 8 is. Could that make a 22?
Yes, it is.
Yeah, if we made this a negative and make this a positive, we'd get a 22. Nice job. And if we get it wrong, what do? We erase, switch around, and do it again, right? Nice job. Okay. Turn the page. Okay, now, this one's different. Before you do this one, listen. Write this up here, write it on top. Always common factor first. Okay, always, 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 I'm going to highlight that. Always common factor first, if you can. If you can. Always common factor first, if you can, all right? So, what does that mean? Well, let me take a look at example 5. I can make example 5 easier. I can make it easier if I can common factor out a 6. Do you see that? I can take out the 6 first, okay? So if I take out the 6, it's going to make this problem easier. So I'm going to common factor out the 6, and then it becomes x squared minus 2x minus 3, okay? Once I do that, then it's yesterday's stuff, because the 6 doesn't count. It's on the outside. So now it's yesterday's stuff. What times what makes 3? 3 and 1, right? Could that make a 2? Sure. This is yesterday's stuff, right? So the 6 is out. There's no number in front of here. So this is just going to go to, you ready? X minus 3, x plus 1. Okay, check it out. Here's my negative 3. If I add them, I get the negative 2, right? And the 6 is still part of the problem, but it's on the outside, okay? So if you can common factor, it makes the problem smaller, which makes it easier to factor. I'll say it again. If you can common factor something out, it makes the problem smaller, which makes it easier to do. Your numbers go from big numbers to small numbers, right? So it's always a good idea if you can common factor. Now, number 6. We're going to solve for x. So what I'm going to need to do is factor, and then I'm going to need my mini equations, okay? Remember that from yesterday? All right, so example 6. Do you see anything that we should do first? Can we common factor out the 5? You guys agree with that? Multiple 5, multiple 5, multiple 5. And when I take out and common factor out the 5, the problem gets easier, okay? So if I factor out the 5, I get a x squared. 5 goes into 15 3 times. 5 goes into 50 10 times, okay? And now the problem's easier, okay? So keep the 5 there. The 5 is still part of the problem, okay? Keep the 5 there. Okay, parentheses, parentheses, right? All right. What times what makes 10? 2 and 5, right? Can that make a negative 3? Yeah. How about an x, what? Minus 5x. Awesome. And by common factoring, it made it a lot easier. You guys agree? Now, how many answers? How many answers? We talked about it yesterday. How many answers? 2 answers, right? The 5 does not have an x. The 5 doesn't count. So my mini equations come from x minus 5 equals 0 and x plus 2 equals 0. See, the 5 does not have an x, does it? So you're not going to get an answer for the 5, but you get plus 5, x equals 5 minus 2, x equals negative 2, okay? So when do we solve? When we have an equal sign. Remember that? When do we solve? When we have an equal sign. That's when you get your mini equations and solve it. Okay, now let's look at our journal.